So what we thought we would do is move this screen to forward. Spend a little bit of time on why NEC is interested in software-defined networking, and give you an update on NEC's OpenFlow-based networking product line called ProgrammableFlow. Samrat is going to talk about some of the implications of a software-defined network for network design, and we're going to give you a sneak peek to a new version that we're going to release very soon of OpenFlow. So we appreciate the chance to have you here, and want to give you a little insight on what we're doing. For those of you that aren't familiar with NEC, we are a $35 billion worldwide company. We're in the IT, communications, and service industries. So we have vast experience in designing entire systems, in developing solutions for customers. So we have a lot of experience in the challenges of managing network and IT. We also do about $3.5 billion in R&D investment. So this has been a major focus of that R&D activity over the last couple of years. In the US, we have offices everywhere, and we are focused in providing a complete set of infrastructure solutions, from servers to storage to software, and today we're going to focus on that.
Sorry, he said cloud.
Oh, he said cloud too.
Oh.
Oh, wait, did the keyword come out?
Yeah.
Yeah.
Yeah. We're jerks.
That's actually two. You're very good. You started with paradigm.
No, sorry, we're jerks.
Okay, well, we're going to shift the paradigm and talk about solution focus.
I predicted that.
What does Gardner say about this?
Later on in the slides.
Were you in the magic quadrant?
Yes. So NEC does deliver these solutions, and so making them easier to install, deploy, and manage is part of the reason why we're interested in software-defined networks. So spend a couple minutes thinking about how the challenges of networking industry manifest today. So in the traditional model of deploying networks, we had these silos of compute infrastructure that we were able to build closely aligned network infrastructure tied to that. But with virtualization, we now have these virtual machines running all across the data center, and new applications spreading out across the data center. And what we really need is, get that to stop. What we really need is a network infrastructure that does the same thing. That is, that we can leverage the network infrastructure the same way that virtualization has allowed us to virtualize the compute infrastructure. So what we really need is that ability to reduce CapEx and improve OpEx on the network side the same way that virtualization has allowed us to do that on the compute side. And obviously, cloud is a large opportunity, both public cloud, but importantly for us, the private cloud becomes part of that solution.
Can I ask a stupid question? Cloud is obviously a buzzword and a keyword that many companies, many vendors use for different things. When you say cloud, what do you actually mean by that?
We talk about the public cloud, the private cloud, and the hybrid cloud.
Okay, but what is it?
So for our customers, it's about automating processes so they can deliver services without having to build tickets. Ultimately, it's about providing a complete solution that allows them to deliver services on a more automated basis.
So I think it sounds like infrastructure as a service is what you're referring to in particular.
It's just that to understand
So
what your understanding of cloud is.
Yeah, so from NEC's perspective in the US, we provide infrastructure as a service, both as a solution and as infrastructure. And NEC more globally is doing end-to-end solution stack. So it depends on the market and the infrastructure that we're going after. Okay. Some recent research that ESG did shows sort of how many networks the administrators are administering. So we start to see that the level of complexity in a network design increasing with the number of VLANs and subnets that these organizations are running. And so getting to that level of automation becomes increasingly critical as they have these larger networks that they need to manage. We will probably debug this at some point. In that research, they asked, what is your biggest challenge in managing a data center network? And the number one issue was too many manual processes. So really, this automation is key. Associated with that, the delays associated with configuration change management. So having agility within their infrastructure becomes really critical, along with integration with their IT and the ability to maintain. So these were the sort of top things that came out of this research, and probably the people in this room already understand and live with this every day. So the analysts covering the industry are beginning to catch up to where the maybe the operations people already are. That the industry's traditional model of a distributed network doesn't really address these problems in a more fundamental way, and so we continue to layer on complexity to solve these problems. This is where a software-defined networking model comes in. In the traditional model, we have the control plane and the data plane on the switch. This model has served us very well, but doesn't allow us to provide that level of automation that the cloud needs. And so with this new software-defined model, we're able to move the network intelligence up into the application stack for the first time. This eliminates the need for traditional network protocols like spanning tree in that OpenFlow space in the network, greatly simplifying the network management and providing us, for the first time, really an open interface to control how data packets get forwarded across the network. It also provides us a centralized model for managing network automation, and provides us this ability to virtualize the network so that the physical devices hanging on the network are no longer tightly coupled with their location in the network. For this reason, the ONF has taken charge in developing a new open standards-based model for networking, and led by some of the largest data center companies in the world, because they see a real need for this new model of an open network standard. So with that, NEC built the ProgrammableFlow product line. The ProgrammableFlow product line was the first software-defined OpenFlow-based fabric. It provides us this ability to virtualize the network and to apply this solution to a variety of different applications. The solution consists of a controller and a family of switches. We introduced the controller and first member of the switch family at Interop, where we won Best of Interop, and subsequently introduced the 10G switch in October. The ProgrammableFlow controller is a OpenFlow 1.0 device. That is, it runs the OpenFlow 1.0 specification. It is a Linux appliance and runs as a piece of software running in an appliance. We'll talk about the controller appliance architecture and how we build upon OpenFlow to build the solutions for a variety of different applications in Samrat's presentation. The 5240 was our second generation OpenFlow enabled switch. It provides, it's a hybrid switch, so it runs all layer 2, layer 3 protocols and OpenFlow, sort of ships in the night. We greatly expanded the OpenFlow capacity for the second generation switch, so it can control up to 56,000 full ACL-based flow table entries. So it's a very high performance switch for a data center type application.
Question?
Yes.
You said ships in the night, I suppose referring to the fact that you can have both OpenFlow-based packet forwarding and you can have the traditional packet forwarding in the same device, right?
That's right.
Does this mean that they are isolated from each other, or there is a possibility to communicate between the two? And if the answer is that they can communicate, how do you prevent things like loops forming in that mixed environment?
No, they don't communicate on the backplane. That's why they're ships in the night.
So they are completely isolated from each other. There is no way to provide inside switch communication between the two. If I wanted to communicate between the two, I would have to pass it to external loopback, right? Okay. Fair enough.
What is the flow rate on this one? Like how many flows per second could you set up? If you were doing that on a flow by flow basis?
What's the metric?
Wait, that kind of brings up an interesting
Dan,
point.
he asked you about the flow.
Yeah, I was
Number of
going to
flows.
say what the metrics.
You can set up the max 800 to 1,000 flows per second, because the path from the switch to the controller, that processing the CPU and mostly the CPU bottleneck is in the switch. That how many packets you can process over the secure channel to the controller. So effectively, it comes to around 800 to 1,000.
So that brings up an interesting point. Something I've seen about people who might criticize OpenFlow is that there is a limit on the number of flows per second on these switches that you can do. But my question to them has always been, there was some article on Networking World recently where where the author was talking, I forget who wrote it.
Probably Doug Goulet.
Yeah, I think you're right.
I wonder what.
He's not a world's biggest fan of OpenFlow.
Right. Well, one of the points he was making, if I recall correctly, and I might inquire incorrectly, was that the number of flows per second is relatively low versus the number of flows that we're going to see on a network. But my understanding is that OpenFlow is not meant to control every individual flow that you see on a network, every source and destination address for TCP.
right.
Doug is using the stupidities that some academics are throwing out to discredit OpenFlow.
Right.
Right.
Because if you look at what those academics have written, they have never even seen a running network.
Yeah, that's true.
Yeah.
Yes. Well,
So-
you would still put masked entries in there. It's just it's a question.
Yeah, I mean, certainly there could be a limitation, but I mean, if you think about how many times on a switch we have to update a CAN table or a forwarding table or TCAN.
The problem is link failure.
Mm-hmm.
So if you have a 10,000 entry routing table and the link fails, and they can install 1,000 entries per second, that's 10-second outage.
Well, would you? This would be a question.
What they have to do is, and that's all in my blog post. Sorry.
Okay.
Oh, there we go. The master spammer strikes again.
You have to create sort of virtual circuits across the
That's true.
OpenFlow core.
Okay.
Yeah.
And would it be possible? I don't know the answer to this. Would it be possible to program in into the forwarding tables like secondary?
Yeah, it is.
Yeah.
It is how it is done.
Okay.
So the secondary is already created.
But
So
you
for a link
can-
failure, we just
They have the
move.
same problem as loop-free alternate. So you can do that in a triangle. You can't do that in a square.
Okay.
Sorry.
So the 5820 we introduced back in the fall. It's 48 port 10G SFP plus 4 port QSFP for a total of 64 ports 10G in a 1U form factor. So this is 1.28 terabits backplane, and this is an OpenFlow device. We focus on, as a layer 2, it has 96,000 flow entries, and on a full 12-tuple match, it has 750 entries.
So is this Trident chipset or your own?
It is merchant silicon.
Yeah. Okay. The specs are like every other switch I've seen in the last year.
So part of the goal is, and maybe we talk about this in the next couple slides, is really to build an infrastructure on commodity solutions rather than
Why reinvent the wheel?
Yeah,
Don't
that
we
makes
understand, right?
No, no, I just ask.
Yeah, the value in an SDN network is in the controller,
Right.
Absolutely.
not in the fact that there's a balls to the wall,
Yep.
V8 engine under the hood.
Well, so we can say right now that the implementation of the OpenFlow spec on the switch does matter.
Yeah.
That will become progressively less important over time, but right now you can see significant differences in the way
Yes.
the OpenFlow is implemented.
Yeah, for sure. Yeah. But my point is, it's not about speeds and feeds on the switch. It's the value you derive from an OF network is in the software.
Absolutely.
Yeah.
More the greater part of the value.
That's right.
But there's an important point that he mentioned that we glossed over. Even though everyone is using the same hardware, the path from the CPU to the TCAM is not the same on every switch.
Yeah.
Right.
And
So with the
that's
same
what matters, but
hardware,
that's
you
still
get
software, right?
totally different OpenFlow performance.
By OpenFlow performance, you mean
Flow installation rate.
Flow installation rate,
Yeah.
not the actual forwarding
No,
rate, which is
no,
yeah,
that's,
yeah,
Forwarding
yeah,
is
yeah.
that's
software.
version silicon.
Just to make it up.
Yes.
Yeah, well, and how would I guess another question would be about that is how would OpenFlow flow rate installation compare with traditional layer 2 learning and layer 3 routing protocols?
No, you see, that's the catch. Layer 2 learning is done in silicon. That's why it's fast.
But it's
Layer
but
3
hold on a second. It's not fast at all because it's terribly inefficient. Because you have to generate the traffic to learn where the
Marco,
traffic is.
I'm saying that the flow installation rate for layer 2 learning
Okay.
Would be
is
comparatively
fast
slow. Yeah.
because it's done all in hardware. On the other hand, every single router vendor has a problem with TCAM downloads. That's why prefix-independent conversions and loop-free alternates were invented in the first place. Because Cisco and Juniper couldn't push the routing table into Ceph and on the line cards fast enough. So this is way slower than what those guys are doing, but still, it is a generic problem.
Okay. We'll talk about layer 2 convergence and how this compares later on. Hopefully you'll like that. So why would an organization look at a software-defined network? We think there are both CapEx and OpEx benefits. In terms of the CapEx, you're going to get improved asset utilization. You're no longer running spanning tree. You no longer have to terminate VLANs at a single point. And so you get much better asset utilization on the network side. But because you can control flows, you can also get improvements in the appliances that you use in the network and the server utilization because you can now place VMs anywhere within the data center. So a lot of benefits that extend beyond the network for asset utilization. We talked about the ability to use commodity hardware to do these special applications and the ability to virtualize the network, that is to provide independence between the hardware and the software. And then to be able to scale out. So with this model, you can incrementally scale out the network and not have to buy large systems in the core in order to support the same kind of services you would in a traditional model.
Well, now that you mentioned scale out, now I have to ask this question. How many switches can you support with one controller?
Today, the general guidance is 25.
Okay.
But it really depends on the application, right? Sure. So if you have
an change rate.
Yeah, exactly.
How many switches can you run under one controller?
Sorry.
In terms of OpEx benefits, we're shortening network provisioning. In terms of providing new services, we can do that virtually, hit commit, and these new virtual networks get created. We're going to demonstrate that. So that decreases the complexity and speeds the delivery of the services. It also speeds troubleshooting because we now can see those better. And provides, because we have end-to-end visibility, OpenFlow gives us this ability to see how traffic is going across the network and to create individual filters to provide us more visibility on individual flows, so we can actually see what's going on in a very fine-grained basis. And finally, reduce data center power consumption. Power is not, on the network, is not that large of consumption, but by being able to migrate flows across the network, we now can turn things off. And so we have much more flexibility in the way the services are deployed across the network.
So why everyone is playing this one, and it's been in OpenFlow marketing materials since the very first press release about OpenFlow 2 years or so ago. And no one has ever said, why can't you do this in the old-fashioned data center? I mean,
so
there is graceful shutdown that you can use on the routers and on the switches unless they run spamming tree. And so you could do the same thing if you want to. It's just that no one is doing it.
Well, it comes back to a point that you mentioned earlier, Ivan, with failover. Graceful shutdown is fairly easy to accomplish. It's like a backup. I don't care about shutting the switches off. I care about what happens when something goes wrong and I need to power them back up. What kind of latency are you looking at? If I have a failure in the network and I need to all of a sudden power up, a third of my data center because I was shutting it off to save the electric bill, what happens if I'm working in an environment where the cost savings that I've accumulated over the course of 9 months of shutting the switches down evaporate because I couldn't get the switches back up fast enough for all the flows to fail over whenever one of the racks goes down? So you need to make sure that in the event that you want to do something like that, that your timers are tuned just right so that you can bring those things back online almost instantaneously. And so you're walking a really fine edge there.
We do that with VMware now, and it takes a long time to boot a server. But there's no reason for the whole farm of servers to be running all night.
I don't think the application here though is for redundancy. This is for like bursting, right? If you're at peak, you're going to have everything powered up, and you're going to have some kind of threshold-based power up of the switches that are idle, so you can distribute flows across the available bandwidth. Right? Is that what you're thinking?
yeah, that's right. Yeah. So an example we've deployed in our development center. We have two data centers, and every night we need to balance the workload. So being able to redirect traffic to a secondary data center because it's now where the testing is going on, and to be able to do that on a drag and drop basis is different than how we had done it in the past, and more difficult in traditional model.
There is a comment on Twitter that I really like right now, and it goes back to something that Ivan asked before about the maximum number of switches per controller. And the comment goes, I'll read it. So OpenFlow in dense switch environments, we're going to see stacks and stacks of controllers with only 25 switches per controller. Now, I have two questions there. I mean, it's a valid point. In large deployments, 25 switches per controller is kind of pathetic. And the second thing is, how do you network the controllers?
So come back in October, we'll have more to talk about that.
Yeah.
Fair enough. Yeah, I know your
25
answer.
switches in the modern network is actually a lot of switches, right?
It's not at 48.4 top of racks.
Yeah.
I mean, when we're starting to talk about these network fabrics, we're starting to talk about OpenFlow fabrics. You're doing top of rack, and you're doing dissected cores at top of rack.
No,
it's
4
not
by 10 gig ports will give you 250 servers.
Yeah.
But we're talking high density environments. This scales fine in medium density environments.
And
in high density environments, it doesn't.
And but nobody's technology scales well in high density environments.
But think about what this is though. But this, if you look at it differently though, this is really a 25 line card switch. This is network single system image that they're doing.
Yeah.
And those line cards can exist across multiple racks. They don't have to be all in the same chassis. And I think that's what I think that's really where a lot of this stuff on the left-hand side with the virtualization, and we'll get into tech slides. Actually, this is CapEx and OpEx.
Yep, let's keep going.
I don't know what that is.
But I didn't get the answer to my question. How do you network the controllers?
spanning tree.
What was that, Marco?
How do you network the controller?
Yeah, and that's the thing that I'm most curious
Oh,
about.
that's to come back in the October.
Oh yeah, no, sorry. Is your question what's the management network
wha-
look like?
How do you connect islands of 25 switches together?
Absolutely.
How do you solve the problem of what
50
happens?
switches.
Okay. There are multiple problems here. What happens when the controller fails? How do you maintain the flows? Obviously, you don't maintain the flows unless there is a controller redundancy. If there is a controller redundancy, how do you network the controllers when the controller is dead? The second thing is
Okay, stop there. So, the controller is deployed in production in an active standby mode. So we have dual copies. They are sharing memory synchronization, so failover is relatively quick.
Fair enough. For 25 switches, I have 50 switches.
So we will be updating. This is software implementation, so we will be updating.
No,
the number of
you have a
switches that we
limitation
support.
of 25 switches per controller. That's fine. You are going to have a limitation of number of switches per controller. It's going. Yeah, is it going to be?
It's going to be some number, yes.
Is it going to be 500? But let's say that I have more than that. That means that I have to
You create two different controller
two
domains.
different controller clusters. How
Yes.
do you interconnect them?
The controllers.
Yeah.
Come back in October.
How
Come back in
okay.
October.
Let's come back in the October.
So
answer.
the entire controller network right now is a legacy network.
Fair enough. And
I
what?
thought it was spanning tree.
No. I know. That's the management of the controllers. But how do we get the flow that begins in one island, in one cluster, and we get the traffic to go to that controller, or maybe not to controller, through the switches, and switch over to another switch, and go to someplace else? How do you interconnect these islands?
Two islands, right?
Two
so
islands.
so the data side islands are connected just pure data plane. So one switch in one controller domain directly linked to the other switch in the other controller domain.
Fair enough. What if I have multiple links? I have problem of the loops, and how do I increase the capacity?
Right. So right now, one controller domain to the other controller domain is either by mlag or lag.
Okay.
So there is nothing like spanning or anything going on
Okay.
because we don't.
So if you're,
We only support lag
so
and
the
mlags.
proposal would be NEC's value.
Okay,
in this hang on.
Sorry, no, he just triggered something. Can you run spanning tree with the outside worlds or not?
No,
Thank you.
lag.
Okay, you nailed it. So as long if we want to have a single interconnecting link between the islands, that's fine. If I want to increase the capacity with multiple links, I would run the link aggregation, and that's good. But there is no loop prevention that happens there. Okay, that's
Right.
so works
Now,
for me.
If you were
I'm
to
asking them.
bite off on the value prop of this, in my mind, you would start off with a pilot network with 5 to 10 switches in it. Okay, get this running, and then in 6 months' time, you'd come back and reevaluate your strategy, and you'd look at the roadmap and say, okay, we'll be able to scale out past 25 switches in October, or some point in the future. Right?
No, I'm,
So it's not an unreasonable.
No, not criticizing here. Just want to understand how are you going to approach some of the scaling issues that people might be seeing. That's for the benefit of others.
Well,
My
there's
network has 2 switches. So
There's
I'm
a
fine.
scale of reference we're missing though. Like, why is 25 bad? You know, that's
It just sounds bad.
right.
It just
And
sounds.
It
too
does,
bad.
but
It doesn't sound bad, and anything we're mentioning here is not a criticism. Don't get us wrong. It's just that we need to understand the limitations.
And don't get us
if-
wrong on another level. You are the guys with, as far as I understand, the only working OpenFlow implementation. So I mean, good.
but I
Exactly.
think the point is not about 25. What his point is that even if it becomes, let's say, 100, but you still have a boundary, and
Yes.
then how you scale.
Exactly.
And that's where
That's the point.
that's where there are 3 things to say. One is that we are trying to have right now is 2 peering, like one controller peering with the other control, and the control path and the data is just like lags.
Yep.
Yeah.
In the level next, what we are trying to do is that the controllers then become like a distributed controllers.
Yeah.
And the third level is that you can virtualize across the controllers.
That's what I wanted to hear. But
That's in the roadmap.
to make it clear, it doesn't exist now.
No.
It's a feature that works in PowerPoint.
Exactly.
Yeah.
Right now it's a peering, and the peering works, pretty good from a management standpoint, it's a problem that you are now programming a controller and a controller and a controller. What happens in future is that you're managing just one controller as a one unified controller, multiple controllers. But it still works. I mean, the system is not bad. It's just like the way the peering system works. That you have multiple peers and each thing is just working on its own.
The only thing is that it brings up a lot of legacy issues that you're experiencing now. So it's an endless cycle. But I just wanted to see. I mean, it's important for people who are considering some of your products and some of the things that you guys are developing. I mean, where are they going to be in 6 months? So it's a good thing.
It's true.
If I could just insert here, this is great discussion. We would encourage your questions because, you know, this is really...
Don't worry.
Don't worry. You know, this will go back into our development team, et cetera, right? But the other thing that I don't think you mentioned, Don, is today you'll be sharing with them a sneak peek at this new controller and what's coming.
Yeah, let's
so I saw you kind of go, what drag and drop?
Oh no, that's a totally different story. I have my opinion about people who move VMs between data centers, and I will not share it in public.
Okay. Let's keep going. I want to get to the. I want to see.
I don't want to sidetrack this too much, but I mean, I kind of got spanked on the statement of 25 and stacks of controllers. That was my comment.
That's you. Okay.
But the trick is this: OpenFlow isn't something that is understood greatly by a large portion of the networking community. There is a huge group of legacy people who are going to start adopting this after this is thought out here and after it's discussed here. So people are going to hear 25 switches per controller, and I don't care if that means 10 million servers ultimately, they're going to hear 25 access points per WLC. It's what they're going to hear initially until they understand it better. So there's a legacy discussion that you guys are going to have to beat in order not to convince me, but to convince the wider public who run data centers and who bring consultants in and stuff, so we have better talking points around it.
Right, so our argument is there's a lot of really useful things you can do within this network, and hopefully you'll see that in the next couple slides.